Hello everyone. In this video, we will discuss some basic multiple choice questions which you must know to have an understanding of microprocessors 8085, 8086 and little bit about microcontroller 8051. So in these multiple choice questions, the first question is in 8085 microprocessor, how many opcodes are present? So you know the width of data bus in 8085 is 8 bit. So 2 to the power 8 is 256. So there are possibilities of 256 opcodes in 8085, but only 246 codes are defined. So the right answer for this question is 246. The next question in this series is what is the capacity of memory accessible through 8085? So maximum memory in 8085, if you have remember, then what should be the right answer for this question? In 8085, you have 16-bit address buses. So 2 to the power 16 becomes 64 KB. So 64 KB is the right answer for this second question. Think about the question number 3. What is the length of flag register and total number of defined flags in 8085? So basically these are two basic questions. First is what is the length of flag register, and second one, how many defined flags is there in 8085? So you have to recall the topic 8085, then you are able to find the answer. So the option is 8-bit and 8, 16-bit 8, 8-bit 5 and 16-bit 5. So in 8085, the length of flag register is 8-bit and we have 5 defined flags in 8085 like sign flag, zero flag, carry flag, auxiliary flag and parity flag. So C should be the answer for this question. Let's see. Yes, C is the answer for this question. Next question is defined categories for interrupts in 8085. So how many possible categories is there for interrupts in 8085? You can also define the interrupts in 8085 in hardware and software category. You can also define the category like maskable and non-maskable. And one category is also possible in 8085, that is vector and non-vector. So I think all three categories is there for interrupts in 8085. That's why D should be the answer for this question. Let's see. Yes, D is the answer for this question. So question number 5 is right combination regarding 8085. So the option A is trap. It is a non-maskable interrupt. INTR. It is a non-vectored interrupt. So trap is also related to RST 4.5 or trap is also called RST 4.5. So right combination regarding 8085 interrupt. So I think all these three combinations are right. So because trap is a non-maskable interrupt, INTR is non-vector and trap is also called RST 4.5. So let's see. D should be the answer for this question. Yes, D is the answer for this question number 5. Question number 6. Width of data bus and address bus in 8085. If you have remembered pin diagram about 8085, then you have 8 data buses D0 to D7. A15, but the lower order address buses multiplex with data buses. So question is about width of data bus and address bus. So we can say 8-bit is the width for data bus and 16 is the width for address bus and 8085. So what should be the right answer for this question? 8-bit and 16-bit. Okay, so option A is right for this question. Yes, option A is right for this question. Let's see. What about question number 7? Which of the following represents direct addressing mode in 8085? So the first instruction is LDA, means load accumulator, and the data is given. This is 16-bit data in hexadecimal. The second is move immediately, and 8-bit data is given. The third instruction is DAA, and the fourth instruction is LDXB. So which of the following represent direct addressing mode in 8085? So in this addressing mode, address should be directly available and in the form of some 16-bit data. So 16-bit data is available only in instruction 1. So which of the following represent direct address mode? So option A should be the right answer for this question. Yes, answer A is the right answer for this question. Next, which of the following is a one byte instruction in 8085? So first of all, 1 byte reserved for opcode. If 8-bit data is available, this is the second byte of instruction. If 16-bit data is available, then it is the third byte of instruction. So in the instruction 1, jump and one 16-bit address is given. So jump have 8-bit opcode and 16-bit data, so 2 byte is there. So jump and the given address, it is 3-byte instruction. And similarly in option B, so one opcode for LDA instruction and 16-bit data is given. So this is also 3-byte instruction. Move AB. So in this C, no data is directly given. So the complete instructions just related to the only 1 byte of opcode. And let's see for D. D is the 2-byte instruction because one byte for opcode to MBI and 898, this is 8-bit data, so 2 byte. So the question is about 1 byte instruction. So C should be the right answer because in C no directly data is available, only opcode is available to move AB. So this is 1 byte instruction in 8085. So let's see. Yes, this is the right answer for 1 byte instructions. The instruction in A is a 3-byte, instruction B is a 3-byte, instruction in D is a 2-byte. So 1 byte instruction is only move AB. Which flag is not used for conditional instruction in 8085? So basically 5 flags are defined for 8085: size, 0, sign, 0, auxiliary carry, and parity, and carry. Okay. So 4 option is given and which flag is not used for conditional instruction. So we can also jump over sign flag because jump positive, jump minus is there, and the option B is a 0 flag. So jump if 0, jump if not 0 is also instructions available. The third one is auxiliary carry, and option D is parity. So we can also jump over parity, but I think only carry flag is used for jump instructions or conditional jump. So which flag is not used for conditional instruction? So I think C should be the right answer for this question because we use only out carry or final carry for the conditional instructions, not auxiliary carry. So C should be the answer for this question. Yes, auxiliary carry cannot be used for the conditional instruction. The instruction DAA utilizes for binary addition, decimal addition, hexadecimal addition, and BCD addition. Okay, in 8085, either you have to give 8-bit data or 16-bit data. If 8-bit data is there, then we call it data. If 16-bit data is available, we consider it like address. Address is there. So for numerical value, 8-bit data is there and 16-bit data is there. And all data represented as a hexadecimal. Okay. So if we utilize to add two hexadecimal number, then uh, we follow this addition using BCD addition, because in hexadecimal number each bit represents the BCD code or 4-bit binary number. So the DAA, the instructions of 8085 utilizes for BCD addition, because binary decimal hexadecimal addition is not directly happens in 8085. If some addition is happens, it is always follows the BCD addition rules. So BCD addition. So the instruction used for BCD addition in 8085. Okay, so these multiple choice questions were related to 8085. Now let's see few multiple choice question about 8086 microprocessor. So the 11th question in this series, or first question in 8086 is width of data bus and address bus for 8086. This question is very basic. If you start to read any microprocessor. So in 8085, we have width of data bus as 8-bit and width of address bus is 16-bit in 8085. But what about 8086? In 8086, we have 16 data buses, because 8086 is the 16-bit processor. So 16 data buses is there, and we have total 20 address bus in 8086. So width of data bus and address bus for 8086 would be 16 and 20. Let's see which option showing 16 and 20 combination. So option B should be the right choice for this question. The width of data bus is 16-bit and width of address bus is 20-bit. So option B should be right. Yes, option B is the right option for this question. Let's see next question. The next question is which works as a program counter to 8086. Okay, in 8085 program counter is also known as PC, but here no directly program counter or PC is given in the option. So here for 8086 is a different name for program counter. Let's see stack pointer, base pointer, and instruction pointer and source index. So for this question, stack pointer is not used for the program counter purpose. Base pointer, instruction pointer. Instruction pointer holds the address for next instruction to be executed, and this is the this is the same function for program counter in 8085. So I think instruction pointer works as a program counter to 8086, because program counter in 8085 and instruction pointer in 8086 both have same functions, means to store the address of next instruction. So option C should be right choice for this question. Let's see. Yes, instruction pointer works as a program counter to the 8086 microprocessor. The next question is about which of the following is not a data copy or transfer instruction. So the first instruction is given move. In move, we use to move the data from destination to source or source to destination. The second is in, and this instruction related to the IU port. So it is also used for data transfer. And DAE. DAE comes under the arithmetic instruction, because it is used while doing the BCD addition, and out instruction is also related to the IU port or IU devices. So which of the following is not a data copy or data transfer instruction? So option C should be the right choice for this. Yes, DAA is not used for the data copy or transfer purpose. The next question is instructions used for data copy or transfer regarding IO ports. So basically for regarding IO ports, we require read operation and write operation. And for read operation and write operation in context of IO, we use only two instructions, in and out. So these in and out is the only instruction related to the IO port. So let's see, in, exchange, move out, in, out. So option C holds both the instructions in and out, which are related to the IO port. So we can say instructions used for data copy. Yes, for data copy, data transfer, we use in and out regarding IO ports. So option C should be the right choice for this question. Yes, this is the right answer. For 14th questions, let's see what is the next question. Yes, next question is about addressing mode. Instruction move AX and BX represents which addressing mode? So if we talk about the registers given, so register AX and register BX both are 16-bit register in 8086, but the square bracket around BX, it shows we have to consider the content of register BX for addressing purpose. Also, the content of BX can be considered as an address. So which addressing mode? Immediate addressing mode means no directly data given in the instructions. Direct addressing mode, no address directly given in the instructions. Indirect mode and register mode. If move AX BX is there, then we can say this is the register mode because source and destination both are register. But in this case, we are using DX for address purpose. So this instruction is related to the indirect addressing mode. So option C should be the right choice for this question. Instruction move AX square bracket BX represent which addressing mode? So this is indirect addressing mode. Let's see. Yes, this is the example of indirect addressing mode. Next question. Hardware interrupt of 8086. If we recall the pin diagram of 8086 microprocessor, we will find INTR. INTR is there and NMI, non-maskable interrupt. Okay, so in 8086 pin diagram, we have two pins INTR, NMI for hardware interrupt. So hardware interrupt of 8086. So C should be the right answer because this is around none of the above. We will find INTR, NMI, both pins in 8086. So both A and B. So hardware interrupt of 8086 INTR, NMI. So C should be the right answer for this question. Let's see. Yes, C is the right answer. Means INTR and NMI both are hardware interrupt of 8086. The instructions move AX and 16-bit data is given and square bracket is also showing the address. Illustrate addressing mode. Okay, move AX, the address is given and square bracket. So the instruction move illustrate addressing mode. So options are immediate addressing mode, direct addressing mode, indirect addressing mode, register addressing mode. So this example relate to the direct addressing mode because here we are giving the 16-bit data for address purpose. So it is the direct addressing mode. Okay. So this is the direct addressing mode to the 8086. Yes, direct addressing mode. So this is example for direct addressing mode in 8086. Capacity of 8086 to be connected with the maximum number of coprocessor in minimum and maximum mode. Okay, so 8086 can work for minimum mode and maximum mode. In minimum mode, 8086 is the only processor to the system. So in this case, we will not find any other coprocessor. Okay. So maximum number of coprocessor in minimum mode. So this should be 0 because in minimum mode only 8086 is the processor. So no coprocessor available for minimum mode. And maximum mode. So for 0 coprocessor in minimum mode, we have two options, option A and option D. Okay. And maximum mode. Okay, for maximum mode, I think 3 coprocessors is the maximum capacity. 3 coprocessors is the maximum capacity of 8086 and maximum mode. So the combination of 0, 3. Option D should be the answer for this question. Let's see. Yes, option D is right for this question number 80. Next question. Next question is about which one is not an assembler directive. Okay, assembler directives are the commands to the assembler. So option A is given assume. So we will easily find this. So this is one assembler directive. A group is also an assembler directive. We can group two segments in a one segment by using this assembler directive. Then C exchange. So exchange is the instruction. Exchange is the instruction in 8086. It is not an assembler directive. And what is the next? ORG. ORG is also an assembler directive to start the memory address. Okay, from where memory is started or segment started or so ORG related to the assembler directives. So assume is assembler directive, group is assembler directive, ORG is assembler directive. So which one is not an assembler directive? So exchange is not an assembler directive, it is an instruction in 8086. So C is the right one for this question. Yes, exchange is the instruction, not an assembler directive. Approximate threshold for number of instructions in macros and procedure. Macros and procedure both facilitate modularity in programming and both can be considered as a short programs, but the macros don't require call and return instructions. This is a very short code written for modularity, and procedures use call and return. So for call and return purpose, we require multiple instructions and procedure, and whatever the small code defined for procedure, it is able to perform some specific tasks. So we will easily consider macros have few instructions in comparison to procedure. And what is the approximate threshold for number of instructions in macro and procedure? So the first thing you have to note down approximate threshold. So for approximate threshold, we cannot say this exactly this number of instructions hold. So the option A is macros have 10 instructions and procedures have greater than 10 instructions. And option B, macros have less than 10 instructions, procedures have exactly 10 instructions. And in option C, macros may have less than 10 instructions and procedure may have greater than 10 instructions. So these two are approximate threshold. And option D is like assignment category, like in macros have 10 instructions and procedure have 10 instructions. But the question is about approximate threshold for number of instructions. So option C should be the right choice for this one. Macros may have less than 10 instructions, procedure may have greater than 10 instructions. Let's see. Yes, option C is right for this question. What about next? Oh, these few questions are related. These few questions were related to 8086 microprocessor. Let's see what questions here given for 8051. Okay, for 8051, the question is 8051 holds, fill in the blanks, IU ports. Okay, so 1, 2, 3, 4. 8051 holds 4 IU ports. Okay, if you find the pin diagram for 8051, you got 8051 holds 4 IU ports. So 4 is the right answer for this fill in the blanks question. Yes, 4 is the right answer for question number 21. The next question is about 8051 has 16-bit register. Okay, so 8051 is a 8-bit microcontroller. So not all registers defined for 16-bit, but in 8051, in 8051 we have two 16-bit registers. Okay, if you find an overview and introduction part of 8051, somewhere it is mentioned 8051 has two 16-bit registers. Okay. Yes, 8051 has only two 16-bit registers. Okay. I think one of them is a DPTR, and I'm not remember exactly the second one, but 8051 has only two 16-bit registers there. The next question is the capacity of read-only memory and random access memory in 8051. So what is the combination? 4 KB, 128 byte, and option B is 128 byte and 4 KB. The option C is 8 KB, 128 byte, and D is 128 byte and 8 KB. Okay, so the capacity of ROM and RAM in 8051. So the RAM in 8051 is 128 byte. So RAM in 8051 128 byte. So this option indicates option A and option C. RAM is 128 byte, and this is 4 KB. 4 KB 8051 has 4 KB ROM. So option A is right for this question. 8051 has 4 KB ROM and 128 byte RAM. Yes, option A is right for this question. Means memory about 8051. The next question is 8051 follows architecture. Okay, the option is von Neumann, Harvard, both A and B, none of the above. If you remember, microprocessor 8085, 8086 both follows von Neumann architecture. Means the single or the same memory for data saving and code saving. But in microcontrollers like 8051, we have separate memory for data and programs. So this Harvard 8051 is a microcontroller, and microcontroller follows Harvard architecture. So option B is the right answer for this question. Yes, Harvard architecture. 8051 follows Harvard architecture. In this, we have separate memory for data and program. Width of data bus and address bus in 8051. Width of data bus and address bus in 8051. For shortcut purpose and to remember this thing, you should know this point. 8051 has similar width of data bus and address bus like 8085 microprocessor. So what is the combination for 8085? 8-bit data bus and 16-bit address bus. So 8-bit data bus and 16-bit address bus, and this is given in option D. So I think option D is the right answer for this question. Yes, 8-bit data bus and 16-bit address bus available in 8051 microcontroller. Let's see what is next. The question. Okay, so these are the multiple choice questions, or like very basic multiple choice question about 8085 microprocessor, 8086 microprocessor, and microcontroller 8051. And few important questions you must know about 8085 like pin diagram, architecture, addressing mode, interrupt. And for 8086, this is like pin diagram, architecture, addressing mode, flag register, and minimum maximum mode. Yes, minimum maximum mode is defined for 8086. Assembler directors, what are assembler directors, and micros and procedure. ALPs for one's complement, two's complement. This ALP holds the like logical instructions, or you can also perform one's complement, two's complement using NOT operation. Logical operations is there. So for one's complement, we can use only NOT operation. And for two's complement, we require one logical operation NOT and adding extra one. So we require one arithmetic instructions. And for this arithmetic instruction, either you can add one or you can increment the one's complement. So this is also equal to adding one. So you have to write ALP for one's complement, two's complement using logical and arithmetic instructions. And you should know also about the overview and architecture of 8051. So these theory questions are important or like basic questions about microprocessor and microcontrollers. And let's see. Okay, so this is all about these slides. Now, thank you very much for paying attention.